At this class, we will learn about renewable and non-renewable energy sources. Do you want to go further? See you in the board. Okay, now let's explain what is energy. Recall that energy is all the time said in joules, okay? In joules. So we have two kinds of renewable of energies, renewable and non renewable. What does it mean? And how I can realize or recognize that is renewable or non renewable. And the main point is that the energy source is in effect. The energy source is in effect. That's why this is renewable. For instance, the wind, solar, and the hydro. Okay, why? Because the wind is no wasted or is no affected by consuming that energy or by transforming that energy. That's why it's renewable. Okay, the solar one, because the sun is in effect when we are getting that energy, when we are transforming that energy. Okay, then the source of energy is in effect at all. Okay, the hydro, because we are leveraging the rivers, the sea, or whatever fluent flowing, right? So that's how we are going to use that force. All the flows, that is kinetic motion or the kinetic movement or the kinetic energy, it will be transformed into electricity energy. Okay, so that's why the main feature of this is that is the energy source is in effect. Okay, we have three main kinds of these energies. The wind is also depending of the turbines. The solar is depending on the photons or the electrons in flow. Okay, and the hydra is dependent to the potential energy. Okay, that's the potential equation. That's mass, gravity, and height. Okay, so those are the renewable. Those are also called green energies. Green energies is related to the green of our planet, because those energies are not affecting our planet at all. So that's why those are renewable. Recall this, it's not affecting the source of energy. And what are the non renewable? uh, the first main point of this is that the energy source is affected. Okay, here is affected, or it runs out. What does it mean? That the energy is runs out, is running out. Okay, so that's why we are running on currently fuels, combustion plus efficiency. Then we are combusting petroleum, coal, fuel, wood, gas, oil. Those are our current fuels. Okay, and we have another kind, that is the nuclear one. This nuclear one is depending of the nuclear or the radioactive materials. Okay, we have the krypton, we have the plutonium, we have a long list of radioactive um, materials. Okay, so the mass, we have to recall this amazing equation. Okay, here, this is the equation of Albert Einstein. He has said that if we accelerate the mass up to the light speed at up to square, it will be transformed into energy. Okay, so that's why. If you want to go further, you're going to go further, of course. So now you need to make a summary. We are we are learning about renewable and non-renewable energies. Okay, the first is that the source of energy in one is not affect, versus the another one that the source of energy is running out. Okay, so based on this, we are going to say, oh, that's why the petroleum is limited, gas is limited, oil is limited, coal is limited, wood is limited, because our our way of getting the energy from that sources is running out. Okay, so that's the main point. That's why we have efficiency. is not the same one if we burn petroleum than if we burn coal. If just imagine yourself making a grill with petroleum. The food will not taste nothing apart petroleum, right? Coal is the most common, right? Then the common one is coal. Fuel. Oh my gosh, all the meats or all the food will taste to full, and also to gas and oil. That's why we have efficiency. What is efficiency? That petroleum produce more energy than coal, or that the coal produce more energy than the fuel, and gas and oils and so on. All of this is related to how much of the material we could be using or combusting. Okay, so the equation of this is the energy that we will see in the next video. We will do a lot of all those exercises. So the first part of this is to understand what is the energy, where is the energy currently coming from, and which kind of energy sources we are running out. Currently, we are running out the coal, the wood, the petroleum, the oil, and the gas. We need to find more and more sources of energy. That's why we need more green energy types. So if you are going to be using energy, try to use green energy. Okay, so recall this. We are able to produce energy. We can produce energy by rotating something. And we will see this in the next part. Then see you in the next part. And the most common way of producing energy is by rotating turbines connected to an electromagnetic generator. What does it mean? That we have to have a kind of electric motor. In this case, it's called turbines, or in also electromagnetic generators. And we are going to move this. Let's check it out. Okay, you're going to be able to see, okay, in the next video, how much energy we can produce. Okay, we can produce energy. How? We are going to check it. But the first point is to know that based on Faraday's law, this Faraday's law is staying this equation. This equation is saying that regarding the diameter of the turbine and other and other terms, we will be able to find out this amount. Okay, so this is the way of producing energy, just by moving or by rotating turbines. What is a turbine? It can be a turbine. How it could be producing energy? Let's check it out. So, okay, now we are in this part. Now, here, let me please show you how to produce energy based on Faraday's law. Okay, it will not produce a lot of energy because it is now a huge radio or huge diameter. Check it out here. Okay, I'm producing energy. Oh my gosh, faster, more energy. As fast, more energy I get. If I spin it in the another way, it will be positive, right? Versus in the another way that is going to be negative. Okay, this is the most common way of producing energy. And how does an hydroelectric works? Let's imagine this being moved by the falling of the water. That's how an hydroelectric is working. Okay, it's producing energy, and that energy now here is not connected no more. Okay, and that energy six. Let me try to get one volt. Okay, now that's how we can